Hello friends, my name is Ankit Agarwal and I will be discussing face recognition using Fisherfaces and Eigenfaces. So the outline of my presentation includes introduction, biometrics, history, what is face recognition, project preview, training set, Eigenface algorithm, Fisherface algorithm, demonstration, comparison between Eigenface and the Fisherface algorithm, and the conclusion. Starting with the introduction, machines have taken over almost every aspect of our lives. Everyday actions are handled electronically instead of on paper or face to face. This increasing growth in the electronic transactions results in great demand for fast and accurate user identification and authentication. Pins for identification and security clearances are being used for bank accounts, access codes for buildings, and computer systems. Using PIN grants access to the user, but the identity of the user is not verified. When credit and ATM cards are lost or stolen, an unauthorized user can often come up with the correct personal codes. Face recognition technology can solve these problems since a face is undeniably connected to its owner. Now, what is biometric? A biometric is a unique, measurable characteristic of a human being that can be used to automatically recognize an individual or verify an individual's identity. Biometrics can measure both physiological and behavioral characteristics. Physiological biometrics measurements and data derived from direct measurement of a part of the human body. Behavioral biometrics measurements and data derived from an action being performed by a human. Now, these can be divided into two types. The physiological are like finger scan, facial recognition, iris scan, retina scan, etc. Behavioral are like voice scan, signature scan, etc. Now, what is face recognition? Every person has characteristics and features that are unique and specific to their face. Human face is the most common and widely used feature for identifying a person. Face detection versus face recognition. Now, face detection is based on identifying a face or non face, while face recognition is identifying a face and recognizing it. Now, there are two types of comparison. Now, one is verification, in which we have to tell that the two faces are similar or not. Another is face identification, in which we have to identify from a given data set which face it belongs to. Now, the four steps involved in any face recognition technique are capturing, which refers to capturing the image of the person whose face is to be recognized. Second part is extraction, which is feature extraction, extracting the unique characteristics of the face. The third part is comparison, comparing it to the mean image or some parameters that are predefined while training the dataset. Fourth is the result, whether you found a match or not. Now, project preview. In our project, we are aiming to develop an algorithm that gives the best way to recognize a human face, even if there is a variation in illumination, pose, or facial expression. The project gives a brief description of two face recognition techniques, that is, Fisherface and Eigenface method of face recognition. The project also shows the comparison between the accuracy of the Fisherface and Eigenface algorithm. Now, what is it? What is the training set that we are using? We have taken the images from the Yale Face database. This database consists of 165 images of 15 subjects, that is 11 images per subject. Now let us see our dataset. Now, this is our dataset consisting of 165 images. For the subject 1, this is a normal face. For the subject 1, this is a face with glasses. Similarly, this is a happy face. This is a face in which the light is projected from the left. This is a face with no glasses on. This is a face in which the light is projected from the right. This is a sad face for the same subject. This is a sleepy face for the same subject. Similarly, a surprised face and a wink face. All these face kind of expressions are recorded for 16 people, which consist of our dataset. Now let us look at the Eigenface algorithm. In this algorithm, we use principal component analysis. It involves projecting face images from a higher dimension to a lower dimension. The lower dimension images are known as eigenimages. Eigenfaces have one drawback, that is, it cannot handle illumination effectively. Now, what is PCA? PCA is the principal component analysis. It helps in finding the principal component of data and builds n eigenvectors for an image of size m cross n and are ordered from the largest to the smallest. Around 90% of the total variance is present within the 5 to 10% of the dimensions. Now let us go through the flowchart for the face recognition. The first step is obtaining a training dataset. Then finding the mean image. Then finding the deviations and centered images and compute eigenfaces. These three steps include a training phase. Now we have to test the image. We feed the test image into a system. We find the eigenface components and compute the Euclidean distances from all the mean images in our dataset. Now we find the distance between the mean image and the calculated Euclidean images. If the mean distance is less than the minimum Euclidean distance threshold, then the image is displayed. Otherwise, there is no match. Now let us look at the Fisherface algorithm. This algorithm is based on linear discriminant analysis technique derived from the Fisher's linear discriminant technique. Data is assumed to be uniformly distributed in each class. The aim of Fisherface is to maximize the ratio of the between class scatter matrix and within class scatter matrix. It produces good and error-free results even when the illumination is varying. Now let us check the demonstration of a code. Let us start with the Eigenface algorithm. This is our code for Eigenface algorithm. Now, as we can see, three figures have been popped up. Now, this is the first figure in which we can see first 16 eigenfaces projected. In the image 2, that is figure 4, according to these three are the classes that is projected in the 3D spaces. And this image shows us the reconstruction of the image from the eigenvectors. When we use 10 eigenvectors, this kind of image is formed. Using 30 improves the image. As we increase the number of eigenvectors into the image, we get clearer images. As we can see, after using 310 eigenvectors, the image is almost like original image. Now let us check Fisher face. Okay, so this figure shows the first 16 Fisher faces projected. This figure shows the three classes that is projected into 3D space. This is by Fisher face algorithm. And these are the two images that is being presented when we are trying to reevaluate the image from the eigenvectors. Now let us check the validation of the two codes and compare the results. We are using a 10-fold cross validation in this process. As we can see, the eigenfaces have shown the accuracy of 98.25%, whereas Fisher faces show the accuracy of 95.75%. So we can say that eigenfaces gives better results than Fisher faces. Now let us go back to our presentation. The comparison between the Fisher face and the eigenface. Eigenface tries to maximize variation, while Fisher-face tries to maximize mean distance between various classes and minimize the variance within class. Fisher-face is based on LDA criterion, while the eigenface is based on PCA. The LDA uses training labels while PCA is unsupervised, hence, among the two Fisher-faces gives a better result. Fisher-face takes lesser space as well as has a lower error rate in comparison to eigen. Now, what do you mean by unsupervised? In case of unsupervised learning, we don't have the right output, so we have to train our data based on the inputs, and the machine has to learn on the basis of the input. Now we come to the conclusion. An efficient face recognition system was set up that gave eigenfaces, Fisher faces, and also the validation between the two. The results obtained indicated the Fisher face method had lesser error rate and gives a better face recognition system. Application of this system is in surveillance, human computer interface, and law enforcement. So I terminate my presentation over here. Thank you.